My name is Tomasz Kowal. I'm working at Club Collect company, and what we're doing is reversed Robin Hood scheme, which means we take from the poor and give to the rich. But actually we're collecting money from sports club members and then pay it out to treasurers. Sometimes those sports clubs aren't really rich. But for those people that tend to those clubs, it's usually a chore to pay, because it's not always the same amount. They can just do standing order, because for example this month there was a barbecue and they have like €5 more to pay or something like that. So we automate this process by using usually SEPA direct debits. So we take money from their account and then pay it out to treasurers. But of course we want to support as many payment methods as we can, so that it's really easy for the end customer. And sometimes those payment methods have different quirks. So for example, if you use SEPA direct debit, we take money from your account, but then you can, for a couple of months, click charge back, no strings attached. No one asks you why did you charge back. It's your right to do so. So we need to do all those bookkeeping and then make sure that the money is on correct account, take it from the club. And sometimes it creates strange edge cases. So we had a couple of those, especially if you, for example, change slightly how your algorithm works, it can affect invoices from the past and stuff goes really strange really quickly. So we thought out that maybe we should start using property-based testing that would weed out at least some edge cases. So there are many examples, especially in Elixir community. So for example, Łukasz mentioned a talk by Joseph Valim, the creator of Elixir programming language. And during that talk, Joseph Valim said that they would like to make property-based testing part of the language. But in the end, they decided not to, and I think it's a good idea, because property-based testing frameworks are different beasts. They have their own set of constraints, their own set of trade-offs. So you can use this one or that one, and maybe it wasn't the best idea to make it part of the language, but it speaks about how much of a value is property-based testing for people. And the example he used was really simple. So you generate, you want to test concatenating. So you generate a string that you put on the left, you generate a string that you put on the right, then you test the actual concatenate, and then using standard library string contains, you check if the left string is in the output string and if the right string is in the output string. And that sounds pretty simple, but actually this property is not exhaustive, right? Because, does that work? Oh, that works, nice. So actually if you, for example, write it this way and it reverses the strings, like this property still passes. So it's not exhaustive. Sometimes it gives the wrong impression if you show people properties that are not exhaustive, because in the end they will see that, okay, this property-based testing is for testing data structures, and then in the end you still have to write unit tests. Like that's not true. Another very common example, and even was on the previous presentation, was that if you generate list of any kind of elements, a reverse of a list is the initial list. Again, it's very nice property to teach because it's very short and not a lot of happens there. But again, it's not exhaustive, right? If we supply identity function as our reverse, then it will still pass, right? So like, I don't like tests that say nothing about my code. So that's why after talking with my friends, I've seen that there are some misconceptions about property-based testing, and I want to try to fix a couple of those. So I'll start with success stories. Where do property-based testing is applied? And Łukasz already mentioned Quivic and AUTOSAR, and they found amazing amount of bugs, but actually one of them was really strange. They had a particular radio model that they connected to this AUTOSAR. AUTOSAR is basically a bus in your car, a message bus, and all of the devices need to apply to this strict protocol. And like when you plugged this radio and then turned the volume up, your brakes didn't work. And like that's fantastic thing basically. So what was the problem is the endianness of this particular radio model was wrong. So for all the operations, unit tests and whatever people tried to test, everything worked. But volume up had the lowest of lowest priorities, and with the endianness wrong, it got the highest priority, even higher than your brake. And of course, this radio couldn't be used with AUTOSAR later. But it shows how property-based testing can work. So it generates a set of different things that people wouldn't even think about, and then if you run it again and again, at some point it will find something that you wouldn't even think of. Łukasz already told about the example of LevelDB, like 20 operations to have a problem. This is actually also pretty nice because you wouldn't write that in unit tests, right? Nobody writes examples that have 20 calls in them in unit tests. But if you have a log that shows this 20 specific calls creates a bug, then you can work with it, right? You can go one by one, step by step, and see at what point the problem occurs. So it's big enough to not be possible to test by unit tests, but it's actually small enough for a person to debug. Another cool example is a talk from Lambda Days 2016, and it was by John Hughes. It was about testing Dropbox. So what they did is they wanted to check if Dropbox really synchronizes properly. And this is a hard problem because if you change files on two computers at once, you don't know in which order the operations will come to Dropbox, and what it will do depends on the order of those operations. So what they did is they created a tree of all possible orderings, like all permutations. They've checked, like they had an end result for each leaf in that tree, and then they checked what Dropbox actually does. If what Dropbox did was in one of those leaves, then they said, okay, that works. And they still found some problems when you were able to lose data in Dropbox, not because of the operations you did, but because of Dropbox handling them incorrectly. So these are all those really great examples. And how do you get there? Because most of the talks are usually about testing basic data structures. Then there's like a whole lot of nothing. And then there are those epic success stories, right? So I want to fill that gap, and I want to talk to you today about how do you come up with good properties? What does it mean that the property is good? What are Oracle properties? Somebody mentioned them even during questions. I'll quickly skim through generators and shrinking. I will explain how we handle state in Erlang and Elixir because it's a little bit unique. It's different in statically typed languages. And then I will show how to build models, which is really necessary for building stateful tests that make those epic success stories possible. And then I will show an example of stateful test execution. So I will be jumping a little bit in those sections, like they will seem unconnected at first, but in the end the stateful test execution and how to build models will actually tie everything together, so bear with me. Okay, so this is something that I talked about with Łukasz, about how to actually test this reversal function. And we came up with this solution where we, after generating a list, we take just kth element and check that on the left list it's on the k place, and on the right list it's on the length of list minus k. And this is really powerful example because this time the property is exhaustive. If we supply a wrong function to such a property, it will fail at some point. Maybe our function drops elements when there's more than 1000 of them. even something like that at some point will be discovered, because what we have here is definition of reversal. And this is really important. Like, the definition and implementation are usually different things. And when coming up with properties, we should really think about definitions, not about what it does, and not about how it does it. So there was a question that specifically asked about how do you come up with properties, because when you start writing properties with property-based testing, you focus on the framework itself, and then you re-implement what you want to test in the test. So this isn't re-implementation of reversal. This is a property, but this is an exhaustive property. And that's how you should be writing tests. Sometimes you will need 3 or 4 of those. And I based my presentation on a book by Herbert called Property-Based Testing with Elixir and Proper. And he also has some exercises about how to build good properties. But let's say we want to test a hashing function. Can you come up with a property for a hashing function? Yeah, tricky question. So it's very problematic. Like, you could, again, have those non-exhaustive properties, like the output of a hashing function is always given length. It's pretty basic, but it doesn't really test what the hashing function does. And because hashing function involve randomness, it's very hard to come up with a good property. What can you say? It has enough randomness, but with enough generated inputs, we will at some point cover an example that generates, I don't know, all zeros, or in 32 places, 31 zeros, and that doesn't have enough randomness. So it doesn't make sense. So for places where we really have randomness, we use something that is called oracle property. And the oracle property basically checks that for all given inputs, our algorithm should output the same thing as an oracle. So in case of a hashing function, we could take an implementation from OpenSSL, and then when we write our implementation, we can say, okay, let's check 1000 randomly generated examples if our algorithm returns the same thing as the oracle. And that's a valid method of testing, and this really requires, like, it's a little bit like re-implementation, but it's better to think about it when you have the oracle that is outside of your project. Okay, Łukasz covered generators. I will then quickly skip through it. So if you have, for example, string generator, it will try to start with something small, and not only the length of string will be small, but also initial characters will be, for example, only ASCII. So it tries to be, the generators usually try to be smart, and they increase not only the length of the data structure, but also the size of what is in it. So for example, the most basic letter is only alphabet from ASCII range. Then there may be some numbers and only a couple of characters from ASCII range. Then we can get some Unicode, for example, new lines. And let's say that new line is stuff that breaks our test or our property. In such an example, we don't get that as an output of broken test. Our testing framework tries to shrink the input. So it will try remove some of the characters from the input until it's small enough and it can't remove anything more. If you remove the new line from a failing test that fails because of new line, then it will stop failing. So we can't shrink that. We need to backtrack. And this is very important because in stateful property-based testing, we will actually write our own generator, and we will need to provide it some way to shrink the output. Okay, final thing from those unconnected ones is state management in Erlang and Elixir. So because we don't have types, state monads and stuff like such, if we have some long-running operations, we usually have it as a loop. So we have a function, let's call it a loop. It takes initial state, and then it will call itself recursively with a new state that is computed somewhere in that function. And that sounds pretty simple at first. People sometimes ask if we don't run out of stack, but because this is tail recursive, it's optimized, so everything is cool. It will run like a while loop. And then if we want to communicate with a process in Elixir that has some state, in this loop function, it usually receives some messages. So we send it a command to run. Usually the caller sends its own identifier so that we can reply to that process. So this receive checks what command we've received and from who. And then we try to calculate the reply with some kind of result and the new state. And then we can send that reply to the caller. So that's how we communicate between processes, between long-running processes in Elixir. This is usually abstracted away in a gen server. That's how it is called in Elixir. But what is really important there is that you have your business logic in a set of callbacks called handle call. And the handle call takes the command that we want to run, the caller PID and the state. And later, we can do something by pattern matching, like on this command, let's do something, on another command, let's do something else. Every time, just take and return the new state that we will loop later with. So this is extremely important because these handle call functions can be pure. They don't always have to be pure, but they can be pure. They only transform state and calculate answer. So in the end, testing them is really simple. And also, if we don't have side effects, it will make it much simpler to do stuff like backtracking and calling the same stuff with the same input. We have referential transparency, basically. Okay, so now we try to tie everything like this together. Stateful property-based testing usually takes some system under test, generates a set of commands that we will run on this system, and then we check if the output of our system is the same as output of the model that we've defined. How do we define it? So it looks a little bit like Oracle property, but we define the model ourselves. Again, this is a little bit problematic because people tend to overcomplicate this model or make it similar to the implementation, but actually it should be much simpler. So I've gave this talk already during Lambda Days and ElixirConf, and I've used an example of a patient database where you identify patient by PESELs. I won't give you a run over how PESEL works. Basically, what is important is, probably everyone knows that, is that if someone is born after year 2000, in the date part of the PESEL, we add 20 to the month. So if someone was born January 1st, 2005, the month will be 21 for him. And in our example, we will cover a case where this particular input, where someone is born after 2000, will break. So we will have a very simple database. We only can search patient by its PESEL, or we can add a new patient with name and surname. That's all. Again, very simple example, but it will show how do you approach stateful property-based testing. So how can we model that? Because our database can be really complex from the inside. Like it can have sharding, write stuff to disk, have caching layers, communicate over internet, like a lot of stuff. But the API is really simple. It's a key value store, right? So if we want to model that, preferably in memory, we can use just a simple data structure. right? We can use a map where the key is a pestle and then the value is name and surname in a tuple. As simple as possible. That's how you should write your models. And now that we have something that resembles what we want to do, we need to implement some callbacks that the property-based framework for Elixir uses. And those functions, those callbacks are command that takes the state. We need to implement initial state. Next state is a little bit like the handle call function from the Gen server example. It takes the state, it takes command, and it will return what will happen to the state in our model. Then there are two additional functions called precondition and postcondition. We will get to that in a moment. So firstly, the command generator will generate the commands that we run to our database. We have only two commands that we can run. We can either add a patient or search a patient. So for now we will ignore state, this is denoted by this underscore, and we will say that our commands is either calling the patient DB with search and generated pestle. I'm not covering pestle generation here. Or it can be adding a patient with pestle name and surname. And again, name and surname can be just string generators. It would be usually nice to wrap them if they're not just strings. Then we need to implement the next state function. So we have two cases. In case of search, what do you think will happen to the state? Well, nothing will happen. Nothing will happen to the state because search doesn't change the state of the application. But in case of next state, for adding patient, we are actually putting stuff to the map. So function map put will return the map with this pestle name and surname added. So that makes the next state function pretty simple. We know how the state can change depending on the actions that we do. The precondition answers one question: does it make sense right now? So in our case, all the commands we can interchange and nothing depends on anything, but we will extend the scenario in a bit. Postcondition answers the question, did it work? So you don't have to even put your checks inside the property. Sometimes you do it in the postcondition function because you need to check if something happened for that particular call. Okay, so let's then check how the execution, the naive execution works. Let's say that our command generator generated a couple of commands. So it searches a patient by pestle P1, then adds a patient with pestle P2, then searches yet another patient, and then adds yet another patient, and it goes for 1,000 queries and or commands. And can you spot the problem? Basically we're shooting blanks, right? Because we will generate the pestle every time, so even in 1,000 calls, it's very likely that we will generate a new pestle every time, and we will not test if the data is in our database, right? So that's why stateful property-based testing is a little bit harder than testing data structures. You not only have to come with properties, but you also need to guide the execution a little bit. How can we do it? How can we make sure that the command sequences are meaningful? We will create a smarter set of commands. So instead of just having two for searching and adding, like we had before, we will have search for existing patient, search a missing patient, add a new patient, and add patient with pestle that already exists in the database. So we need to extend the set of commands even though our system has only two functions. Let's say how can we do it. Now we will not be ignoring the state in the command function, we will actually need it. And when we have call to search existing patient, we will say that we take the pestle as one of the keys from the state. So we just randomly take one of the pestles from the state. The same goes for search missing, like we need to ensure that it is not in the database. And let's check how such a guided execution now works. We're searching for not existent PESEL P1, and that's unconditional, like that always works. At least on an empty database, it will always work. Then we have add patient by PESEL 2, then search existing patient. And if we generated a command search existing patient, then we're pretty sure, because we keep the state in our model, that it needs to be patient with PESEL P2. That's the only patient in our database. Then let's say we generated add patient with PESEL P3, and let's say that that one is broken because he was born after 2000, and this is the problematic part. Then we have again search existing patient, and now when we get to that part, our generator would pick either PESEL P2 or P3. So let's say it picked P3. So now those commands are much more meaningful. We actually test if we inserted stuff to the database. And if our test failed, this is not the output we will be given. We're starting the shrinking phase. And that's why we had to implement all those callbacks in the first place. Now, proper will try to remove some commands from the set of commands that we've generated. So if it tries to remove the search non-existing PESEL, it can do it. The test still fails. Everyone is happy. If it tries to remove add patient by PESEL P3, then this command will not have its precondition met, because the patient with PESEL P3 is not in the database anymore. So that's why it will try to remove both of those commands, because the fifth one now doesn't make sense. But after removing those two, the test suddenly passes. So we need to backtrack. This can't be removed. So let's say we try to remove again add patient with PESEL P2. And again, the third command depends on that one. That's checked in the precondition. So we need to remove both of them. And again, proper could try removing that command or this command, and it can't do that without making the test pass. So at some point it will give up and say, okay, these are the two commands that have the data that breaks for you. And this is this exciting part, right? This is what made testing LevelDB possible, because the actual output that was generated and that failed the test initially could have thousands or millions of commands. But this shrinking phase does the magic. It makes sure that you get the minimal counterexample. Okay, so to sum up, there are phases to property-based testing, at least to stateful one. We first need to generate all the commands, and that uses only the model that we provide. It doesn't touch the system that we want to test yet. It needs to be deterministic, so no side effects in those functions, no calling to randomness, except for the functions provided by proper, like one-off. And this phase depends heavily on precondition, because again, if we, for example, want to search for an existing patient and the patient is not there, then it fails. Next phase is actual test execution, and this uses generated calls and checks if the property holds, or uses just the stuff that we define in post conditions. And this phase, if it passes, then it can be pretty quick, right? It doesn't have to do much calculations. It depends on the system under load. And then if the test fails, we have shrinking, and shrinking is basically repeating these two states a couple of times, but instead of generating commands, we try to remove them from the first generated set of commands. So to sum up, there are absolutely epic success stories of property-based testing. Like you just couldn't do stuff that you can do with property-based testing without it. But there's a considerable upfront investment. You need to learn this stuff, you need to define the models, you need to maintain them, and people sometimes even say that it might be better to start using property-based testing only after you have your project written, so that you weed out all the edge cases. Because if your project evolves and you need to evolve its model along with it, that can be pretty cumbersome. We're in our company at the state where we pretty much figured out what we want and what our users want. So now it's the time to actually weed out all those edge cases. During the talk, I've mentioned the book by Herbert, and I can't recommend it enough. It's absolutely awesome. It doesn't only teach you the proper framework, but it also teaches you how to approach property-based testing, how to write good properties. Actually, this entire presentation is just a summary of one of the chapters, which goes into much greater detail about everything that I've said today. So that's all from me. Thank you very much. Any questions?
So if you scroll back to the slide with the transitions that you apply, this is basically
you mean this one?
Yeah. This is basically a finite state, right?
Yes, it is. It is.
So I only briefly looked into proper, but the approach with using kind of like finite state machine generators feels kind of unique to the proper. I know that there is, I use the Haskell implementation. I think it's called quick check state machine. But from what I've seen, Elixir people do use a lot of the kind of approach with state machines.
Yeah, that's correct. So I think in quick check it works very similarly. But because in Elixir you have those pattern matches, so where was the next state definition here? Because you have those pattern matches that I don't even think you have something like deep pattern matching in Haskell. So it's a little bit different. Then like this approach is a little bit easier in Elixir. It would be harder in Haskell. There are also things that are much easier in Haskell. For example, you don't have to specify generators at all for some types in Haskell, because that's just a type, and then the generator is inferred from it. In Elixir, the proper library needs to create a generator for each basic types that Elixir or Erlang have, which is probably more work for the maintainer of the framework. So yeah, there are differences between those frameworks, but on the high level, this is always the same. If it is quick check or proper or whatever else, like this is the standard approach.
And I mean, the way you define the state transitions, this is a finite state machine. So you kind of like, as you mentioned, guide the way the state transitions. I recall a blog post from Oskar Wikström. He does like a Haskell implementation of a screencast editor with like the GUI and things. And he wrote a blog post about how he generates, how he uses property-based testing for generating data for analyzing the transitions. So if you do a screencast, you have things like you don't move slides and then something happens and then something happens on the screen, and the classification is automatic. So if you combine the way you define the state transitions up front in Elixir, the way you have it in here for the vessel, it kind of feels like it's going toward an oracle. Maybe we have like different understanding of an oracle, but you define up front, you define what you expect from what happens step by step.
That's correct. Like I think that's the heart of stateful property-based testing. You first need to define the model and what it does, and then your implementation might be much more detailed and have, as I said, like all those network connections, caches, and whatnot. But you need this simple oracle, and in that case, you really need to re-implement some kind of logic that your machine does. The reward is pretty cool though. For example, recently I had problem configuring my Wi-Fi, and in the end the problem wasn't in my Wi-Fi, it was in my router, because I was asking the DNS server for a new IP, and then sorry, not DNS, DHCP server for an IP, and then the server returned the new IP but without the subnet mask, and my router didn't expect that there can be no subnet mask, and then it did strange things because it thought it's new IP and whatnot. So like testing any kind of protocols where you have different sets of data is very nice with that kind of approach, even if it's just a finite state machine. Also, to define finite state machine, I believe apart from having the initial state, I would also have to include in the state here, like the state I'm in now. Because here, like we can say it's a finite state machine if we just pass a map, right? This isn't the finite state machine. But if I had really in the state variable, I could have the state I'm in, and in precondition I could check if I allow new states there. So we can get to that from this solution without too much work, I think. I think you also had a question?
Yeah. So in practice, does stateful property-based testing effectively become the same as something like TLA plus?
What is TLA plus? I'm not sure. I'm sorry, I'm just not familiar with the term.
Well, like formal verification, where it explores all the possible states that a system could be in, which is especially effective for distributed systems.
Yes and no. Okay, I understand the idea. The problem with TLA plus is that it needs to have some kind of formally checking all the branches in your code, and that sometimes can be much more than the memory will allow, simply. In Haskell, it might be a little bit easier because of the type system. In Elixir, you might expect different kinds of values in different kinds of paths. So if you try to explore everything, it gets pretty big tree. So it might be unverifiable in the end by that method. And because QuickCheck tries to poke around it randomly, or proper tries to poke around it randomly, then you have a high chance that you will uncover new bugs in what you've written, but you don't have to like check everything up front in a tree. So sometimes I think there was a test for something in Erlang virtual machine, pretty basic, like process registry in some kind of old Erlang version, and there was a tutorial on property-based testing, and the teacher was showing this example, and he showed it like many times for many people, and suddenly once during one of the lectures it broke, and the guy was like, what? I didn't change anything in there. And actually he uncovered an error in Erlang virtual machine during the presentation that he didn't know about, but he could copy the inputs, the output, and yeah, it really was an error, and QuickCheck generated it after like, I don't know how many, if he gave 10 lectures, and every time you run 1000 examples and maybe even run it a couple of times with different students, then over time you are guaranteed to uncover all errors, right? But it's a little bit like monkeys typing Shakespeare, if you know that parable. So yeah, it's nice. It can uncover a lot of stuff, especially with testing user input, how they try to break stuff, and especially in places where your domain grows exponentially with states. But again, it doesn't require formal verification that could be much slower. It's somewhere in the middle.
Okay, thank you.
Any other questions? Thank you very much then.